We've moved over here on to do some work on the manifold. That's the plan, at least. Lifted up on the bench here. I've taken the carby off. It's sitting over there. Just inspecting it closely, and I've actually noticed there's a crack there and a matching one in the other side. So where is it? There it is. Matching one on the other side. So what I'm going to do is go out the front and look at the parts tractor and see what condition that's in. Potentially we'll use the manifold off the parts tractor. So we're out here at the parts tractor at the front, and it would appear almost identical crack, actually a little bit bigger. So we will utilize the one in the shed that's already there. Look, it's not a major crack. It actually probably won't even affect how it runs, because it doesn't have anything. It's just exhaust. Yes, it'll be a little bit of an exhaust leak. So looks like I'll put that back together, and if it's ever a drama, we'll have to look into possibly brazing it up or just something. It's just, yeah, it's really cosmetic, and it might have a little bit of an exhaust leak, but we'll see how it goes. Okay, so came out the front, and I've taken the elbow off the parts tractor. It is absolutely mint, and that flapper valve is stuck, but I don't think it's going to be a problem to free up, so we can make sure everything works exactly as it should, which will be great. Looks like there's meant to be some sort of flapper valve in here too. I don't know exactly how it's all meant to work, but we'll find out. We'll have a look at the other ones. Like, hopefully the other one's got something in there. Okay, so I'm really glad I took this one apart. Essentially, the way this person decided it should work is the exhaust should always go through the bottom, which is great as long as you're only ever running on kerosene. So this tractor probably would have ran fine on kerosene, which I guess was all they were using back in the day. But if we had to try to put it back together and not pull this apart, it would have probably boiled the fuel and not wanted to run on petrol. So they've jammed something in here to basically block off the bypass, which is not what we want. So I will, this is just going to go on the other tractor. It'll look fine for decoration out the front. But yeah, this other one that's actually got a flap down the bottom, which will be good because I'll be able to close that flap, probably actually put it on a lever. And I'm not sure I'll bother making anything for the top. I'll probably just leave it open so it gets its full flow, and we'll just hook the linkage to the bottom and leave it closed basically, so I can run it on petrol. But yeah, basically I'm going to try and clean all this up and it'll be happy. Okay, so these manifolds are multiple pieces, which I actually didn't realise, but that's cool. So I've got it pretty much stripped apart. You've got the, this is the intake section, which sits around here like, once I get it right, there you go, like this. So that's the intake section, sits there. This goes down to the carby. And then, of course, you've got the big exhaust pipe sits up here. So I've got it all apart. I'm going to use that exhaust pipe, which came off the parts tractor. Obviously, that intake. And then we've got the all these pieces. Now, this piece here, bolts are broken. That's all right. I'll heat them to get them out. This one's bent. That one's broken. So we'll have to use some heat on that. If I can. So these tractors have water injection, which uses this one's been blocked off, but basically this is the throttle shaft on the carby, and they inside the end here there's a valve. So there's actually here's the valve. There's actually a fitting where there's a line that comes in and out, and essentially as the throttle opens, it allows more and more water through. I don't know exactly, well, I sort of know how it works, but yeah, obviously it's sort of a metered amount of water, and that's how the water injection works to stop it from detonating when it's running on kerosene. We're obviously not going to run water on it, but I'd like to have all the as much of it there as I possibly can so it looks original, and then we'll probably just block it off. So anyway, so that bolt there is plugging the hole where the water line would go in, so we can hopefully put a fitting in that. Yeah, this actually looks in pretty good nick. It's a bit corroded, but I don't think any of the tubes are rusted through. I will make sure, obviously this is where your air intake actually comes through. So I will make sure that that's free flowing so that we don't have any restrictions. Yeah, but I want to get it all as close to right as possible. You know, we've got this far apart, might as well try and get it right. So next time you see me, we'll be over probably at Dad's house to use the oxy, or I'll bring the oxy over here, and we're going to try and get a few broken bolts out, and then we'll try and get it all back together. So we're onto the manifold now. We're going to try and get out a bunch of broken bolts and studs. We're going to start on these ones. This is where the exhaust pipe would run out here and up. So this one's bent, that one's broken. So the plan is, this one we're going to weld this nut to it so we can grab onto it nicely. As you can see, we've got a bit sticking out, which makes that nice. So the combination of the heat going in from welding the nut, and also we'll heat all around here with the oxy. We're hoping that will free it up. And over here, once again, we're just going to heat all around here with the oxy and try to get it out. If we end up having to weld a nut to it, we will. So then we've also got these two bolts. There's one here, there's one here. The heads are broken off them, but it's still all rusted together. So we'll get that heated up and freed up. Same with this one. It should just come out with a bit of heat. That bolt is plugging the hole for the water injection. So yeah, basically a bunch of heat, bunch of welding onto bolts, and we should have this all sorted. So we were unsuccessful. We couldn't get a nut to hold it, and it just didn't want to budge. And this side, when we tried to undo it, it ended up breaking. So what we're going to do is we're going to go to drilling a hole through the guts of it, and then trying to blow it out with the oxy, which we can do. The hole does go right through. If you can see in there, it's shredded right through. So we think that's going to be our next option. So we ground it smooth, and that's where we're going now. So we got a hole drilled through them. I can't remember what size we went up to. It was about probably an 8mm hole, something like that. And what we've done is we've gone through with the oxy and tried to blow as much of it out as we can, much of the bolts out as we can, which we've done reasonably well. So hopefully we can chip away the bits of crap, and then we'll run a tap through to clean it up. Okay, so we got there in the end. As I said, we blew out a lot of it with the oxy, and you can see a lot of the crap down inside the holes there. So we blew a lot of it out, and now we've run a tap through it, and those threads will be perfectly serviceable for what we want to do. So I'm thinking we're probably going to drop this in the mill. I don't think this surface is particularly flat, so we're just going to take whatever it takes to level that off, a couple of thou, and we might even do the sealing surfaces for the manifold onto the head as well. So that's a plan there, and yeah, but we've got to move on to this one here. This one came out, so we'll get this one out. And probably try and get that one out too, which who knows how much have damaged the thread in there. But and those two need to come out, of course. So we'll keep chipping away at it. So we've moved on to this piece. This is the bit that goes on the back of the heater section for the kerosene. So what we've actually done, we heated it up enough that we could get it out of the other section, and the bolts were still stuck in here. We couldn't free them up, so we've drilled them out with the drill press. Basically held it in the vise, drilled it out with the drill press. That worked well. And now we're going to tap them to 5/16, which we're pretty sure is the original size. And yeah, it should be, then we can thread some new bolts into it. Okay, we've moved on to, we're going to try and surface the manifold here. I'm just looking at it, and we actually need to adjust the way we're doing it. I'll show Dad what I mean in a second. It's not flat, but we're essentially, this is what we're going to end up with, and we're going to surface this. We have a surfacing tool here, so we should be able to work out all right. Okay, so what we've done here is we use these two parallel blocks to space it up, because we noticed sitting it on all four of the block surface faces, what would seal to the cylinder head, essentially, it was making it not wanting to sit flat. So doing this means it's now sitting flat here and here, and we're basically using them as our 0 point, and everything will be square off those. So yeah, and now you can see Dave's just setting it up, just trying to get our cut.
We're going to have to change this into the angled one to get
Okay, and we're just going to have to adjust our cutter to get a big enough surface to do what we want to do, but that's not a big deal. So what we're doing here is we're just going to go till it just barely touches, and then we'll do a pass across it just to see how bad it is. I think we're going to find that just where it's probably touching now is going to be the highest point. As you can see, it's just barely skimmed that spot there, which is sort of where we thought was the highest point. Yeah, so we're hoping it's probably only going to take maybe 5-10 thou, but we'll see how it goes. As you can see, it's quite a ways out of square. It's obviously cutting this side over here a lot more than the far side, but we should be able to get it. It'll come good quicker than you think, I reckon. It is a long way out. Shit, it's a long way out of square. Okay, so we're off the mill. We've got this face for the exhaust all cleaned up. Now we've got to figure out how to turn this over, machine the faces that actually meet the head. So our mill doesn't have enough travel to actually do all 4 at once, so we're going to try and do 2 at a time. Not ideal, but for what we're doing, it'll be good enough. So we're going to try and figure out how to set this up now. Okay, so we've got it set up in the mill here. We are using our face that we just machined to as our sort of 0 point. We did originally 0 it off this, like that face is parallel to that face. So once we machine all this flat, we will then shift this across to the other end of the mill, so then we can get the other 2. Our mill just isn't big enough to do it all in one go, but it'll be good enough for what it's going to do. So we got these sealing surfaces for the exhaust ports all done. The way we did it, as I said, was probably not the perfect way, but it is significantly better than it was before. So we're happy with it. Probably the only spot we just didn't quite get deep enough to get all that off, but it is dead smooth. You can't even feel it. It's really just a dirty mark. So that's going to make a really good sealing surface. So hopefully we got no exhaust leaks. And yeah, so really happy about that. This exhaust manifold would probably go a bit further than we originally intended to go with it, but I think we're going to have a really good result. All right. We have moved on to the exhaust elbow. This section, obviously the round section here comes from the heat exchanger, and then this section is the bypass for when you're basically running on petrol. You don't want to heat the manifold anymore. This is the mounting surface. That's, I guess, from the factory, it just leaked. But anyway, so we're going to machine this one flat so we have a good mounting surface to go onto the manifold. As you can see, it's quite pitted and stuff, so hopefully we can get away with, say, 10 thou or so. We've got it clamped down. It is quite an awkward thing to clamp down, but we think this is about the best option. It is sitting in a V-block, and it's clamped down fairly tight here, as tight as we're comfortable with, and it doesn't move. So that's the plan. We'll run it through and, you know, take very small cuts, maybe 5 thou at the most at a time, and go from there. Here we are, we've done the first pass. As you can see, we must have it pretty level because with one pass, we've touched both sides, so I'm really happy about that. But obviously the center is a low point. So I'm going to set it up. I'm going to give it a little bit more down here. This is in metric, by the way. So essentially 2 rotations of this handle is, one rotation of this handle is 2 millimeters. So I just did a 0.2 cut, I think. No, less than a 0.2 cut, in fact. So we'll set the auto feed going. Alright, so essentially this is going to be me for the next little bit. I want to keep taking small cuts because this isn't held as solid as it probably could be. I'd rather take small cuts to get it sorted. Alright, so we've made quite a few passes. As I was saying, we're only moving just a little bit at a time. I don't want to take any big chunks. I don't want to risk damaging it. As you can see, we're getting close. It has touched almost all the way around here. Just a few low spots need to be cleaned up. And it's getting most of the top there as well. So shouldn't be too many more passes. Just to get all those low points out. And that one will be done. We're finished with the machining of this surface. There's a couple of little imperfections, but it's essentially machined the whole way around. Where's my finger? There it is. You know, a couple of imperfections, but there's a nice flat surface all the way around to get a good seal on. I've taken about 2 millimeters or 80 thou off thereabouts to get it to this point. I don't really want to take too much more off if I can avoid it. So that's going to be good enough for what we're doing. The next thing I want to do is test this. Now this here is I guess it's called a heat exchanger. So it heats the intake air after the carby. Now the idea of that is to make it run on kerosene, because the kerosene needs to be heated and vaporized to be able to burn it. So what I want to do is make sure that none of this, see, it's a little bit rotten here, but it's actually in quite good condition. I'm going to fill this with water. Dad made up a cover for us. We plugged the bottom, sealed it up. I'm going to fill it with water and see if it leaks through any of these tubes or any of these joints. If it doesn't, I'm going to leave well enough alone and it's good. If it does, we'll have to look at how we're going to seal it, whether we just actually plug off these holes because we're never going to use it, or whether we do something else. We'll figure that out. But that is the plan now. So that's ready. I'm going to go grab some water and fill it up. Okay, Dad's going to fill it up. And he's just going to fill it just enough to cover that top tube. And we'll let it sit for a few minutes and see if it's going to leak out any of the tubes. There it is. There you go. That's plenty of water. It's filled to the top. And it is looking pretty good. I don't see anywhere where there's water trying to get through. So essentially, if water was getting through here, that would be a vacuum leak, which can make, obviously, getting an engine running and running well, very challenging. So I'm really stoked with that because it looks like it is happy as Larry. So, all right, cool. Well, very happy with that. So here we are. This is now the inlet manifold that we've got mounted up. We're using a right angle block here. That's the, essentially the carby mounts down here, the what do you call it? The heat exchanger, then the carby mounts here. So we mounted that, which is right angles to this. So we're going to machine the head surface where it seals to the head. And then once we do that, we've got to figure out how to flip it and then do it onto the machine. This one here, this surface here will get machined. So they'll be at right angles to each other, which is what we're after. We got the manifold surfaces done where they mount to the head. We have now taken that off and we've mounted it flush here. There's little priming cups that screw into here. We actually managed to get them out. And so we've got the bolt going straight through the guts here. So it's nice and strong. We can bolt it up nice and tight. So that's good. And now we're going to surface this, which, as I said, that would go to the heat exchanger and the carby. So we're going to get this nice and flat. As you can see, someone's actually, I'd say, repaired these threads before. And my guess would be that they never really flattened it off with anything. They used a file or whatever. But anyway, we should be able to get this nice and flat. Hopefully it will only take a couple of small cuts, maybe a millimeter at the most. And then that will be sorted. So that's the plan of attack right now. We'll get into it. Here it is, machined, finished. I'd take off probably a little bit more than I wanted, but I wanted to make sure there was good, flat, clean material around the bolt holes, because particularly this one was all right, because I wanted to be able to obviously pull it down flat and without breaking the ear off or putting any tension on it. So I wanted to make sure that was all flat, which it seems to be. We have a couple of studs to screw in. These are ones that we'd bought for something else, which works out all right. Don't have to make any. So we'll put those two in there. And our manifold is coming together slowly. So we'll move on to the next piece. All right, so this is the last piece to machine. After this, we have to go make a bunch of gaskets and hopefully assemble the manifold. This one we figured out the easiest way was we just got this bit of plate, drilled a couple of holes in it to line up with the holes where the carby mounts. So we already machined that bottom side just by clamping on these pieces, and then we flipped it over, bolted it up, and now we're machining this. You know, maybe a couple more passes, and I think this one will be done. So yeah, pretty happy with this. Next step will be to start assembling and making gaskets and assembling it. So Dad's been over here working on the exhaust elbow. So basically what happens is these two butterflies are linked together. This would be the exhaust going through the heat exchanger to heat up the intake, and this would be the exhaust going straight out and diverting around the heat exchanger. So when we pulled this all apart, this butterfly was actually sitting in the bottom over here. This was all assembled but a bit worn out. The screw was knackered. So Dad's cleaned this one up. That one's all original. And made a new shaft for here. And Dad has made this piece here, goes on the end of the shaft, and the two flat spots actually contact this little pin, and that limits how far it moves. And that's pretty close to what the original was. So yeah, essentially that will work like that. So that's essentially how that's going to work. Somewhere like there, we're just going to tack weld it in there, or weld it properly on there, and then we will turn it. As you can see, 90 degrees, she closes up. So that will all work correctly. And then yeah, these are linked by a rod. So when this one gets closed, this one gets open, and they work together. So that's the plan. Dad's nearly got it finished. And then our manifold's essentially done. I've been making some gaskets. We can look at putting it back on the tractor. Here it is. As you can see, it's a bit of weld on the end. That in the down on the stopper position is straight open, and then it's closed in the other stopper position. So that's good. And then obviously that in the down position as well is closed, which is obviously where we're going to run it 90% of the time. Probably 100% of the time, to be honest. I don't think we'll ever bother trying to run this thing on kerosene. But yeah, so that should be good. As I said, I just got to make up a link to tie these two together, which shouldn't be hard. So yeah, I'm happy with that. And we'll go bolt it on the manifold, and then we can take the manifold back to the tractor, mount it all up, and start finalising and put the carby on and everything. Check it out, assembled manifold. It's all 100% working. Both exhaust flaps working perfectly. There should be a tie bar between them. I'll get that sorted later. But all run as it should. I have blocked it off. I made this gasket that covers where the exhaust would come through the back. And instead of cutting the hole in it, I just blanked it off. So she mint. And all surfaces are nicely machined. So it should all work perfectly. Hey, there you go. You can see that gasket. It all doesn't. It needs to be bolted to the tractor to all, because the inlet and the exhaust are separate manifolds. Now here we have it, back on the tractor. Skipped ahead a little bit. I had to clean up a couple of studs. I ended up having to pinch a couple out of the parts tractor. That's all good. So studs, at the moment it's just been held down by a clamp at the end, clamp at this end. There is obviously two more. But that is held on when I put the heat shields on. So next step, I'll slip the heat shields on, and I'll show you what it looks like after that. You actually end up not being able to see the hold down clamps because the heat shields come over here. But anyway, you'll just have to take my word that there is more hold down clamps in there, and we'll go along a bit more. here it is, all back together and essentially complete. So, as I said, we've got the heat shields on here. They pick up these inner studs, just these little tabs to pull them in. You can sort of see in the gaps there that we've got those hold down clamps to hold it all together. And then, yeah, a couple of fittings. We got these, which I'm not 100% sure, even in the manual it doesn't sort of mention them, but they've all got them, and I believe they are primers. Essentially, you unscrew them, squirt a little bit of fuel in, which goes straight into the inlet, basically right on top of the inlet valves. And then I guess that helps you start it, particularly in a cold climate. Not sure. That'll be something to play with once we get it sort of to the point where it'll run. And then you got the water injection pipe goes in behind there. So that's all good. Got the carby mounted up. Got the throttle linkage rod on here. Obviously the linkage from the dash to the carby isn't on because, well, the dash, if you can call it a dash, isn't there. So yeah, we're making good progress. All right, guys, thank you for joining us again. This one's been a bit of a long one. A lot of work we did on this manifold to get everything to seal nicely. Really stoked with how it's come out. And it's one step. It's probably a big step towards getting this tractor running. We'll see in the next episode where I think I'm probably going to start putting some of the guards and stuff back on. Mainly because I want to be able to put throttle linkages on, which mount to the steering column and to the guards and to everything else. So I'm going to start putting all of that back together because I want to get to a point where, you know, throttle linkages are all together, all that sort of stuff before I even try and start it, just so that I'm not trying to run around and try and put the choke on without the linkages and just stuff like that. I'd rather just get it all together and then start it when it's sort of ready to go. So thanks for joining us. Like, subscribe, and I'll see you in the next video. Bye.